x2, and then I have 2 less than or equal to constraints. So this is my feasible region in here. And the way that things worked out for an optimal solution, we probably got, what do we get here? X1 is equal to 5/2, x2 is equal to 0. Perhaps this, something like this is our optimal point, right? Where this constraint is quite flat, this one is tight, we're right up against the boundary of that constraint, and x1 is positive and x2 is 0. Okay, but if I pick a different objective function value, I might be able to get this as the optimal solution. Okay, so for instance, if I change that to a plus, I'm quite sure that the best thing that I could do, maximizing 3 times x1 plus 5. Is that right? No, no. The other way around. Okay, that's what I wanted to do. I'm quite sure that the best I could do is to make x1 and x2 equal to 0. Is that right? No, is that? Yes, correct. Okay. Does that make sense? So then that would be the optimal solution. And in that case, both of the functional constraints are slack. y1 and y2 would both be positive.
Okay, so what if one of them wasn't slack? Can you guarantee at least one other variable is 0? If you have one of the slack variables is non-zero.
I can pick my objective function, so any one of these corner points is the optimal solution. So I think that answers it. Okay, so I can make it so there's no slack and y. Sorry. Yes.
So the y that you're using, what is the name of like 11 half?
Okay. So what is the value of 11/2 for y2 mean? And that is the difference between the left-hand side and the right-hand side of the second constraint when we plug in x1 and x2. So let's plug in x1 and x2. x1 is 5/2. So x2 is 0. So minus 5/2. How far away is from that? Is that right? They're 11/2 apart, the left-hand side and right-hand side. Minus 5/2, and then 6/2, the difference of 11/2 between left-hand side and right-hand side. And that's a good question. Okay, how are we doing on this? Okay? All right. Now, what made it possible to get started here? The fact that we had a nice canonical form to start with, right? And there's a question about what we're going to do if we don't have canonical forms. So let me